Have you ever wondered why some people absolutely love the thrill of the stock market, while others would rather pay for every insurance policy under the sun? It really all boils down to one thing, risk. But how do economists actually measure our attitude towards it? How do you put a number on a feeling? Well, understanding that is key to basically everything in finance. So let's dive in and really unpack the powerful theory economists built to answer that exact question.
Okay, so we're going to start with a really simple choice. It seems easy on the surface, but it actually reveals something pretty profound about how we make decisions when we don't know what's going to happen.
All right, I've got a question for you, and I want you to really think about it for a sec. There's no right or wrong answer here. Just go with your gut. Which one of these would you pick?
Okay, so here are your two options. Option A, I hand you 45 bucks. Guaranteed, it's yours. Option B, we flip a coin. If it's heads, you get $100. Tails, you get nothing. Now, here's the thing that makes this interesting. If you do the math, that coin flip is worth $50 on average, right? That's its expected value. So technically, it's a better deal than the sure thing.
And yet, a lot of us, maybe even you, feel a really strong pull towards that guaranteed 45 bucks. And that is the puzzle we're here to solve. If we were just cold, hard calculating machines trying to maximize our dollars, the gamble would be a no-brainer. So there has to be something else going on. There's got to be a rational reason why we're willing to take less money just to be safe. To figure that out, we first need to lay down some ground rules. You can think of them as the basic operating principles for making consistent, rational decisions when you're faced with uncertainty.
Economists call these the axioms of rational choice. Now don't worry about the fancy names, the ideas themselves are actually super simple. First, you can make up your mind, and your choices don't run in circles. If you like apples more than bananas, and bananas more than cherries, you're not going to suddenly prefer cherries over apples. Makes sense, right? Second, your feelings are stable. A tiny change in the odds, say from 50% to 50.1%, shouldn't cause you to completely flip your decision. Third, and this one's a biggie, irrelevant stuff shouldn't matter. We'll come back to that. And finally, a complicated gamble is still just a gamble. A series of coin flips can be boiled down to one big lottery with the final odds.
Okay, let's zoom in on that third rule, the independence axiom, because this is really the engine that drives this whole theory. Think about it this way. If you prefer coffee over tea, then you should also prefer coffee plus a free donut over tea plus a free donut. The donut is the same in both cases. It's an irrelevant extra. It shouldn't change your mind about the drink.
And this is exactly why that rule is so important. As this quote says, the independence axiom is the key. It's what allows us to build a simple, clean, linear formula. It guarantees that we can add up the value of different possibilities in a really straightforward way. Without this rule, the math would get incredibly messy really fast.
So when we agree to just follow these basic rational rules, something amazing happens. A really powerful and, beautiful mathematical tool just sort of emerges, and it lets us calculate the value of any risky choice.
And this is it, the expected utility theorem. It's a guarantee. It promises that if you follow those simple rules of rationality, your choices can be perfectly described by this formula. And all it's saying is this: for each possible outcome, you multiply its probability by its personal value to you, its utility, and then you just add it all up. That final number tells you exactly what that gamble is worth to you.
Now, here's a quick but important side note. The actual numbers that your utility function spits out, they don't really matter by themselves. You can stretch the scale, you can shift it up or down, and it won't change a thing about your choices. Think of it like Celsius and Fahrenheit. They use totally different numbers, right? 32 versus 0. But they measure the exact same thing, and they will always agree on which day is hotter. It's the same idea here.
Okay, so let's tie this all back to our original puzzle, the $45 versus the 100 or nothing coin flip. This is where the theory really delivers that big aha moment.
So here's the absolute heart of the matter. We don't make choices based on expected dollars. We make them based on expected utility. It's not about the money itself. It's about what that money can do for us, the happiness, the satisfaction, the security it brings.
And for most of us, that happiness has a very specific shape. It's called diminishing marginal utility. Look, your first $1,000 when you have nothing, that's life-changing. But the $1,000 that takes you from 1 million to 1 million in 1,000, it's nice, but it doesn't change your life nearly as much. This idea creates a curve that starts steep and then flattens out. And that shape, what mathematicians call concave, is the telltale signature of being risk-averse.
This concept lets us define something incredibly useful called the certainty equivalent. It's the answer to a simple question. What's the guaranteed cash amount right now that would make me feel just as good as taking this gamble? It's your personal cash value for that risk.
And once you know your certainty equivalent, you can figure out your risk premium. This is just the gap between the gamble's average payout and what it's actually worth to you. You can think of it as the price you're willing to pay to avoid the stress and uncertainty of the gamble, the fee for a good night's sleep.
So let's go back to our choice. The gamble was worth $50 on average. If you said you'd be just as happy with $45 for sure, then your certainty equivalent is $45. And the difference, 50 minus 45, is $5. That $5 is your risk premium. You're willing to give up $5 of potential gain just to avoid the risk of walking away with nothing.
This is already a huge breakthrough, right? But it gets even better. We can actually go beyond just saying someone is risk-averse and create a standardized way to measure how risk-averse they are.
Okay, I know, the formula looks a little intense, but don't worry about the calculus. All this Arrow-Pratt measure does is measure how sharply your utility function curves at any given level of wealth. That's it. A really sharp curve means you really hate risk. A gentle curve means you're more comfortable with it.
Honestly, the best way to think about this is as a riskometer. It's a tool that gives us a precise reading of your personal distaste for risk. It lets us put a number on it so we can compare different people in a really consistent way.
And this table just puts it all together really nicely. The risk-averse person, they've got that curved utility function, they're willing to pay a risk premium, which means their personal cash value for a gamble is always going to be less than its average payout. The risk-neutral person is our baseline. Their function is a straight line. For them, it is all about the average dollars and nothing else matters.
Here is one last way to think about it that I really like. Imagine your utility function as a road you're driving on. Low-risk aversion is like a gentle, sweeping curve on the highway. No big deal. But high-risk aversion, that's like a terrifying, sharp hairpin turn on a mountain cliff. And that Arrow-Pratt measure, it's just the road sign telling you exactly how sharp that turn up ahead is going to be.
And this brings us to the ultimate payoff. Just like the quote says, we can now make really precise comparisons. If your riskometer reading is consistently higher than mine, we can say objectively that you are more risk-averse. It gives us this incredibly powerful tool to understand and even predict how people are going to behave with their money.
So I'll leave you with this final thought. We've seen that everyone has their own unique utility curve, their own personal riskometer setting. So the question is, how does the specific shape of your curve, your personal feelings about those hairpin turns, quietly steer the biggest financial decisions you make, from the job you choose to the way you save for retirement? It's something worth thinking about.